I have begun. Test, test, test. बोल दे.
Check, check, check. Test.
आ रही है. All right. Value resolution. So just a quick recap. We have completed three modules: setting the stage, scene description, blueprint, and composition basics in the Learn OpenUSD modules. We are on the fourth module, which is called Beyond the Basics. We have completed the overview and prim bars yesterday, and we're going to be moving on with value resolution. A quick recap of prim bars. Prim vars are basically short for primitive variables, which are special attributes that contain extra features. Um, they address a lot of problems in computer graphics like geometric primitives, binding geometric primitives to attributes, and then inherit attributes down namespace to allow sparse authoring of shareable data. And then basically we can construct a USD geom primvars API on different prims using certain Python syntax. Um, we saw the example over here where we basically created three different primitives with different compositions if in color and mesh. So for the first one, this was like a single mesh. Uh, and then second one, we had two mesh with different colors. And then third one, we had vertices as mesh, and where we inserted different colors for each vertice, resulting in a gradient sort of color scheme in the two faces of the rectangle over here. And then in the second example, we basically created a deformation animation, which we were able to view via the USD viewer that we have on our terminal. So basically, we set the time samples and frames for each. So it was between 0 and 90 or 1 and 90. So we could toggle the thing on the time code scale to basically see the deformation happening in real time from a square to a what is this shape called exactly? I don't know. I don't remember this. It's called parallelogram into a
Or
parallelogram.
parallelogram is not. Parallelogram should be parallel. This is
Bro, this is a
rhomboid.
parallelogram.
This is not a parallelogram. This is a rhomboid. Let's ask.
No,
Dude, parallelogram is similar to rectangle. That's not a freaking rectangle. First of all,
look at this. It's
look
it's a
at wow.
parallelogram.
Look at it. Look at it. Look at compare both of them. Compare both of them.
Okay,
And
rhombus. Oh, okay. Like, oh, okay. My bad, my bad. So square is a rhombus. Like
yeah,
equal length is a rhombus.
yes,
And
yes, yes.
okay, okay. I need to revise for Jari. Okay. So yeah, basically that was the code that we saw yesterday in our notebook as well. Let me put the notebook over here. And today we are going to be going over value resolution in composition. So, value resolution. Okay, do you want to start reading or
Like I think we can directly start with
the thing over here?
yes, yes.
Okay.
Well,
Va-
value resolution. It's an it's how OpenUSD figures out the final value of a property or a piece of metadata by looking at all different sources that have information about it. Think of it like solving a puzzle where you have multiple pieces of information from different places and you need to figure out what the final answer should be. Even though value resolution combines many pieces of data together, it's different from composition. Understanding this difference helps you work with USD more effectively. Note: animation splints were recently added to OpenUSD and are also part of value resolution. We will update the lesson to include them soon. So
Wow.
that's some NVIDIA developers. Maybe we can create an issue and they will say, "Brother, we already said that." All right. How does it work? Key differences between composition and value resolution. So composition is a thing that we studied earlier, right? So over here it says that composition is cached value, whereas value resolution is not. When you
Mhm.
open a page or add a new scene data, USD creates an index of the composition logic and result at the prim level for quick access. However, USD doesn't pre-calculate the final values of property. This keeps the system fast and uses less memory.
Got it. I understood this.
Tip: if you need to get the same attribute value many times, you can use special tools like USD attribute query to cache this information yourself. Because this is something we can like remember.
Yeah.
USD attribute query is used for caching basically. Whenever if you want to cache something, we will use USD attribute query.
Mhm.
Composition by composition arc, value resolution varies by data type, right? Composition figures out where all the data comes from and creates an index of sources for each print, whereas value resolution then takes this order list from the strongest to weakest and combines the opinion data according to what type of information it is. Okay. Now resolving different types of data. Go down.
I one second. Composition figures out where all the data comes from and creates an index of sources for each prim. Yeah, I understood this. Value resolution then takes this ordered list from strongest to weakest and combines the opinion data to
Like
what
the
type of.
attributes and everything. So so you remember we have opinions and everything,
Yeah.
metadata and attribute.
Yeah.
So it's going to look at that data because it says value resolution rules vary by data type, right? So first,
Mhm.
since the composition is gonna like index the sources and then compile it from strongest to weakest, we are going to look at the value resolution is going to look at it and then combine the metadata from it, like
Mhm.
it will look at the each layer. So maybe the sub layer has some metadata, then we have other layers, inherit layer and then specializes layer and everything, so
Yeah. Yeah. Yeah.
they will have their own attribute data. So that is the information that value resolution looks for and then decides what type of information it is. So that information can be string, boolean, double, float, depends
Mhm.
upon like what kind of a geometric progression or something that we have created or geometric values that we're trying to create.
Mhm.
Resolving different types of data. So resolving metadata, for most metadata, the rule is simple. The strongest opinion wins, right? Think of it like a voting system. When the most authoritative source gets the final say, So some metadata like prim specifier and attribute type name and several others have special resolution rule. A common metadata type you may encounter with special resolution rules are dictionaries, like custom data. Dictionary combines element by element. So if one layer has custom data key 1, another has custom data key 2, the final result will have both the keys. Okay.
I didn't understand
Metadata.
this. One
Yeah.
second. The first,
This.
this wait, it's a little complicated.
Wow.
I'll own the Android phone of every FBI.
Bro, Android phone.
Dude, it is saying something else. Is it talking about the metadata?
No, I was just asking it about this one as well. One second. Composition is just the act of grouping and sorting. Yeah, I know that. Value resolution is the smart system that actually reads their notes and decides whether to pick just one top answer, merge their list, or blend their dictionaries together based on the data type. Since you're exploring mechanics of value resolution, would like to how. Oh, okay, I understand. And then here is a short analogical breakdown of how OpenUSD handles different types of background data. Standard metadata, the corporate voting system, the rule, the strongest opinion wins completely. Analogy. Think of company voting hierarchy. If the CEO strongly votes for an asset named version 2, the intern weakly votes for version 1, the CEO votes wins 100%, the intern note is thrown out. Dictionaries like custom data, the potluck dinner rule, element by element merging. Instead of fighting for the top spot, layers behave like a potluck dinner. If a weak layer brings pizza key one and a strong layer brings soda key two, OpenUSD doesn't choose between them. It combines the tables, so the final scene gets both pizza and soda. Okay. Custom data. Okay. So some metadata. Okay, now let's read this. Some metadata like prim specifier. Intent for how prim spec should be interpreted in composition. Uh, Value over time, single default value. Some metadata like prim specifier, attribute type name, and several others have special resolution rules. Custom metadata, a common metadata type you may encounter with special resolution rules are dictionaries like custom data. Dictionaries combine element by element, so if one layer has custom data key 1 and another layer has custom data key 2, the final result will have. Oh, okay. It's basically just saying there are like different types of ways to resolve a metadata.
Yeah. But like the most important thing is people will be bringing their own custom data. So OpenUSD is gonna merge those custom data accordingly instead of letting the system decide what to go with.
Mm-hmm.
Resolving relationships works differently because they can multiply targets. Instead of just picking the strongest opinion, USD combines all the opinions about the relationship should wait. Where was that? Okay, about what the relationship should point to, follow specific rules for how to merge list.
Bro, relationships work differently because they have multiple targets. Instead of just picking the strongest opinion,
All the opinions.
USD combines all the opinions about the what the relationship should point to, following specific rules for how to merge lists. That is
You've
lists.
got
Oh,
attributes. So I think we are only resolving everything over here. Like we are getting multiple data from
yeah.
multiple sources, and then I know the gist of what value resolution does is it resolves everything and
I
decides
know that as well.
what data
Yeah, it's
stays,
just
what data
it's
doesn't.
basically a parallel of composition, but it's
It's not
trying.
parallel of composition. It's
It's
after what. It's not where does it? It's not parallel. It's not
bro.
parallel.
It's something like
So
composition, but it's
something
not
like that.
exactly composition.
Read the line again. Composition figures out
Is
where all
cache
the
value
data comes.
resolution is not when you open a stage, you add a new scene data. USD creates an index of composition,
Yeah.
logic, and
Yes.
result prim level for quick access. However, USD doesn't pre-calculate the final value of properties. This
Yes.
value calculation is called
Yes.
value resolution,
Yes.
right? And composition is what?
Go down. Now read the second line. Composition figures out where all the data comes from. So there
I
is nothing.
know, bro. Value
Once,
resolution. I was.
once
That's why I
composition,
said parallel.
it's not parallel. That's what I'm saying. At what point it's saying parallel, dude? It's
I
saying create.
okay.
It's saying again. It says composition figures out where all the data comes from and creates an index. So it's gonna until and unless it creates an index of sources for each prim, then only value resolution will kick in. So there, it's sequential. It's not parallel. You know what parallel means? Parallel
Wait.
means that the data sources are coming over there, and at the same time, value resolution is also computing them. And it says value resolution then takes. It says it doesn't say it does it in parallel. It says value resolution then takes.
I am not saying about if it's gonna happen at the same time. I know composition is gonna create the values in the index
Yeah.
first, and then value resolution will kick in. I know that. I was not.
Mhm.
That's not what I meant.
But
The
parallel means that
process. The
the
process is
the process
similar. The process is similar. That's what I meant.
is
N- Read, motherfucker. Read it.
of open build. In fact, but now say why does it says that the over here? Then
In
copy this
fact,
line.
value resolution explicitly separates in a two-step assembly pipeline, composition, maps, outline. Yeah, that's what I meant.
That
Exactly.
question. Yeah. Then why does this line says that it's gonna first index the sources and then the
Bro,
values?
that is, I know it's sequential. I know I don't mean that it's gonna happen at the same time. I'm saying this again.
No, but
I'm,
ask AI. Now I want to seriously just ask
but
AI.
you're asking the wrong question, brother.
But they are like over here. They're then misinterpreting us. Like they're like
No, no, bro, no. Bro, wait, you
copy
know
that
what
line.
parallel means?
Parallel,
Pa-
like so something that works in parallel.
the
Two,
s-
two
no,
things that are
something which is okay.
two lines are
Parallel,
parallel. Right? Two
two
lines are
lines.
parallel.
I don't mean
One
it
is it to
mathematically over here. I mean it. It's doing some sort of similar job. Some sort of similar job. Like the goal of those jobs are similar. That's what I meant. Look at this. I'll explain it to you. Parallel does not mean that it's happening at the same time over here. That is parallel execution. That I don't mean that. That's what I
Okay.
meant. In fact, okay, read over here. Separates them into two-step assembly pipeline. Composition maps out the family tree. Value resolution actually works that tree to fetch the data. So the goal of both composition and value resolution is similar. That's what I meant.
is value resolution and composition parallel? If yes, then why the fuck the above line says that first it indexes
Bro, you're gonna ask the wrong question and you're gonna get the answer different. That's what I'm
wait,
saying. Yeah,
wait,
you're
let me
you're
just
gonna ask about parallel execution. What I meant parallel was something
this
different. Bro,
this
you're
and
wasting time. You're wasting time.
index sources and then the value resolution takes the order list. Let's see what perplexity says. Like I'm still using ChatGPT, so it's not gonna matter.
Okay, look at this.
So it says over here, no, at least in the way the page explains. So I was purely focused on the way the page was explaining, right? So what it says over here is composition and value resolution are not parallel stages doing the same job,
Bro,
right?
you're
For
that's what I'm saying. I'm not talking about execution. Again, I'm saying I'm not talking about execution. What your question is framing is that are they happening at the same time? No, I don't mean that. They're not happening at the same time. I know that. First
no, you're
composition happens and then value resolution happens. What I meant over here in parallel, like when I said parallel was it's doing some sort of similar job to composition.
value resolution doing some sort of similar job to what was to composition. Let's
Bro,
see.
just read this. It's gone. You are asking the wrong questions in the chat,
Dude,
GPT.
I'm just rephrasing your yes. Yeah, now it says it's doing
Yeah.
something related,
Yeah,
but
that's
it
what
is
I
not
meant.
doing the same
Related.
operation. So then the keyword that you used was wrong. That's what I'm saying. The keyword
But Gemini
parallel
was
was
able to get it.
similar. You need to say similar. I'm not Gemini, bro. That's the thing. Gemini, it reads. Otherwise, investors will sue it. Gemini was not
Okay,
able
read
to
this.
do.
Read this. Read this. To see how they run parallel, imagine a high end restaurant kitchen. Composition is the head chef organizing the recipe book. Okay. It decides what the autumn salad layout combines a
Asking
base.
why are we using parallel keyword? It should be asynchronous then. Asynchronous or
Bro,
synchronous.
why are you fucking so
What is it
focused on
wrong?
parallel?
I am really against using parallel over here.
Okay, bro,
I don't
my
know.
bad. You're right.
Yes.
My bad.
Yes.
I
We need
accept
to
defeat.
use parallel over here. We need to use similar or some
My
other
bad.
keyword.
Oh yeah, let's move.
This
Let's
is
move
how
forward.
car name alone will ask you. CMU will ask you.
Oh, mm.
Similar and parallel is GRE.
Okay. Let me see if we have any views. Mom, dad, please stop. Bro,
So,
my friend.
uh,
Look at chat.
wait.
Neil
Just share
Patel.
it over the screen. Just share it over the screen.
No, I'm not gonna share. He's saying, Mom, dad, please stop fighting.
It's all about clarity, brother. Clarity.
Stream, stream.
Okay.
Oh,
Resolving relationships. Holy shit.
fuck me.
Relationship works differently because they can have multiple targets. Instead of just picking the strongest opinion, USD combines all the opinion about what the relationship should point to, following the specific rules for how to merge a list. That is list operations. I think that's what it's saying. And then we have
Attributes are special because
they have three possible sources of value at each location. Value clips, animation data stored in separate files, time samples, specific value at specific time, and default value, a non-time varying value. Okay, so attributes, we can have three types of attribute. It says value clips, animation data stored in separate files. This is something that we have not
Value
seen.
clips is composition feature that efficiently handles large amounts of time varying data by referencing external time sample layers. Oh, okay. Time samples a specific values at time samples is a time value pair that defines the attribute value at specific time. Yes. And then default value is the timeless static value of an attribute that exists outside of time. Uh,
More water. I need more water. Dude, our
what?
Tiger is not a weighing machine. Dude, you should also get the Renfo one. We can share our
I,
body metrics.
I already have a weighing machine
Scrap
that calculates the
that.
body fat percentage and all that. It has some electrode shit. And I
Hmm.
also have this body fat thing in my gym, so I'm
Oh
not gonna
yeah.
buy anything.
Oh, fuck you.
Okay. Value resolution of attributes in the first two cases also account for time scaling and offset operators, example layer offsets and interpolation for time codes that fall between two explicit time samples. Interpolation for time. Oh, value resolution of the attributes two cases also account for the time scaling and offset operators, example layer offsets. A layer offset adjusts time values when composing layer through sublayers, references, or payloads. Interpolation, I know. Offset operators, example layer offset for time scaling and offset operators.
I think layer offsets are something that moves layer depending upon what time sample it's saying.
Yeah.
That would be the closest guess or analogy over here. Let's focus on the code now. What does it say?
Hmm.
Okay, we are doing the usual
Bro, wait,
stuff.
let me ask this part to Gemini. What I don't understand what layer offset is, and how OpenUSD decides the final value of property like size, position, or color when animation is involved. Here is the explanation. Core meaning when the computer asks what value of an attribute right now, what's the it checks up to three different places to find the answer. Value clips, animation data kept in entirely separate files, usually for massive datasets like crowd cycles or heavy fluid simulations. Time samples, specific snapshots, yeah, default value, static value, fallback, value used if there is no animation at all. Flipping through a flipbook, imagine you are looking at a hand-drawn flipbook animation of a bouncing ball, but you have also have static statue of the same ball on your desk. Default
See,
value.
this is what I was saying. Layers,
Uh-huh,
multiple.
default. Hmm. I see. Okay, default value, the statue. If you don't look at the flipbook at all, You just look at the statue, it never moves, it never changes, it just sits outside of time sample, the key drawing there. These are the actual pages you drew in the flipbook, for example, page. What the fuck is this analogy, bro? I don't understand this. Imagine you're looking at a hand-drawn flipbook animation of a bouncing ball, but you also have a static statue of the same ball on your desk. Default, the statue. Oh, okay. Got it, got it.
Brother, for us to
Got
matches
it,
up.
got it. I was just zoned out. It never moves, it never changes. Okay, time samples, key drawing. There are actual pages you drew in the flip book. Example, page 10 shows the ball on top, page 20 shows it sitting on the hitting the ground. Pre-made animation pack. Instead of drawing the pages yourself, you buy a pre-drawn flipbook packet of generic bounce from another artist and stick it in. Oh, okay. And value clips are done by uh also count for time scaling. Okay. The text mentions handling offset, scales, and interpolation. In our flipbook analogy, this means the computer is smart enough to do three things automatically. Interpolation is, I know. Yes. Fast forward, it can flip through your pages twice as fast if you want a high speed animation. Uh-huh. Offset, delaying the start. It can tell the flipbook, don't start playing your animation until I reach frame 50 of my main movie. What is offset, bro? I don't understand what is offset.
It says delaying the start. Offsets. Dude, offset is like you have a set and then you're moving it ahead or forward. Dude, what do you mean? What do you want to know? Layer offset. Like that is the most simplest way I can explain it to you. Like what is offset?
I'm bleeding. What the fuck? Oh, they just like the playback track, five
Was it
seconds.
something different than I said? Was it
Bro,
something
you're not
different?
Gemini, That's what you said,
Mhm.
right? You're
That's
not
what I'm
Gemini.
saying. That's what I'm
Oh,
saying.
fuck.
Even Gemini is saying you the same thing about offset delaying the start. No, you want to the DJ part. Of your offset. Stop wasting your time. Stop wasting the time.
Okay, working with Python. Go for it.
We have a stage, then we are creating a prem
Yeah.
onto that stage, and then we are assigning an no,
Attribute.
we are
Getting an
assigning
attribute.
an attribute. Okay, this so we are assuming there is an attribute named my attribute in the prim. We are getting that, and then we are getting the default value of that attribute using dot get, and then we are assigning, and then we are getting the we are getting the value of the attribute at
At
time code,
time code 100.
right? And then what are we doing over here? We are doing use the earliest time to
Earliest
okay. So
animated values if they exist.
yeah, I see. So if we use the earliest time and use usd.timecode API, we can get the value of the attribute at the earliest time, maybe the initial time or at which the animation should start. So when you get an attribute value without an explicit time code, the default time code is usually not what you want. If your
Mm.
stage has information, instead you use USD time code earliest time to make sure you get the actual animated values. Okay, so if we use default, then what do we get? I'm confused now.
When you get an attribute value without an explicit time code, the default time code is usually not what you want. If you want if your stage has animation, instead use
As
USD
Gemini, there's a difference between default and earliest time as default. Like
to make
what
sure you get the
what
actual animated values rather than the default value. Earliest time is basically when the time code is zero, I guess.
or no. It's not zero. It's something that was set at initial point. It could be anything. It's not actually zero.
The first frame, right?
Yeah, but it's not. But what about what does default return? I'm like I want to
I
know
think we're
that.
gonna learn over here, bro.
No. Go up. I don't think so.
Mm, yeah, over here, look at this default.
Where's default? It's scale. It's not time.
Oh, wait.
Yeah. But I just want to know the value. What is it gonna return? Just
Or
ask Gemini over there. What will default return and what will earliest return?
read. Timeless
Uh,
static fallback value authored directly in the default
default.
field.
Oh, outside of any animation track. So it's like looking at a frozen statue of an object before the movie starts playing.
But that is something that default has been authored. Like a static fallback value is authored directly in the default field.
Yep.
Analogy, it's like looking at a frozen
And
statue of an
then
object before the movie starts playing. If no static default value was ever written, it fallbacks to the hard-coded schema default, like one for, oh, okay. What USD time code earliest time returns the result. It looks across the time sampled animation track and returns the very first animated keyframe value. Yeah, that's what I said. Very first keyframe.
oh, the animated keyframe value is something else.
It's like skipping
Animated
straight to the very first. Bro, look at this. It's like
no,
skipping
but
straight to the very
is
first
it
frame
gonna be
of.
no. You said it's gonna be zero. Is it gonna be zero? I just want to
Okay,
make sure. That, yeah.
okay. It's not gonna be the zero. It's gonna be the very first animated keyframe value.
Yeah. So it could be at any point. That's what I'm saying. It could be at any point, not at zero though.
Mm-hmm.
It could be zero, but not necessarily that it should be zero or it would be zero
Mm-hmm.
necessarily. Necessarily. Fuck, my
It's
S's are fucked.
skipping. It's like skipping to the very first frame of a flipbook animation to see where the
So the
movement
first four
begins.
pages of a flipbook can be empty, right? Then you will see nothing.
Mm-hmm.
Nothing.
Oh, where movement begins. Okay. Earliest. So this is like a good code practice that we need to get USD time code earliest time always
Yes.
for so that we don't have like static animation
Yes.
on the scene description or on the scene composition, I guess.
Yes. All right. Now
Mm.
let's take a look at example one: attribute value resolution and
Oh,
animation. The examples.
What
shows
the fuck?
proved it's gonna be so. Yeah, this is what I was talking about.
Oh my god. The complexity is increasing exponentially.
Yeah, it's not exponentially. It's linearly.
Oh my
Exponentially
god.
would be
My
something
bad.
when we draw something like Amazon warehouse
Oh. Whoa, 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 whoa. Okay.
from
Oh,
PXI port USD geom. Time setting. Start
this is
TC equal to 1 and TC is time 120. Then oh you see now this is the cube animation start time. It's at 60. So this would be your
earliest.
earliest
Yeah,
code,
yeah,
yes.
yeah.
Mid T
Bro, wait.
Q. Oh yeah, it's basically like the finding out the mid time and then we have
But
time
why
code.
are we doing this?
We'll
It's
find
probably.
out
Oh, okay.
once we move through the code complete. Like it's
Bro,
I
let
think we
me get my dinner.
are.
One sec. Oh, but मेरे को लगा कि मैं स्लिक बनूंगा बट नहीं मैं भाई फेंक दिया था मैंने बट व्हाट O2 O2 yeah. All right, motherfuckers, the king is back. Right, I think I'm gonna do one live stream for fight analysis as well.
For sure, brother, for sure, do it.
Do you want to join me on that stream?
Yeah, I would be joining it as an audience. I would be just there watching because I don't know
We'll
nothing
be
about.
putting big money on my boy Justin. Big money.
Let's hype it up. Let's hype it up. We
Yeah.
want. more money. We,
One of
bro,
the angel investors has already put
angel
on like
investors
he
for
has
like I
already
think
put in like
million
40
or
bucks. All right, let me open up the Jupyter notebook. What is this value evaluation? Let me see if it's running. I mean, it will run. Hmm. Some crazy ass shit over here. I think the code would not be so complex. It's just looking very big, but
yeah, it's not that complex. Let's go through it. What we
okay.
have over here is
All right. So mid T is equal to cube anim start TC plus NTC divided by 2. So this plus this, which is 180 divided by 2 is 90. So mid T is 90. Time code per second is 30. Do you remember what time code was exactly? I think
no, no,
per.
I don't remember. So I wanted to do a recap on it.
Wait. This one.
You can ask Gemini, right? Right over there. What is
Yeah,
time
yeah,
code?
I know, but let's read it over here real quick. I think we'll remember. Mm, time code and time sample shows us. Uh, time code is a point in time with no unit assigned to it. You can think of these as frames whose units are derived from the stage. Time samples refer to the individual time varying values associated with an attribute. Each attribute can have a collection of time samples that map time code to the attribute's data type values, allowing for animation over time. Okay. The time code ordinates at all time samples are scaled to seconds based on time code per second, metadata value defined in the root layer. This allows, okay, so that is probably this time code per second that is defined
Yeah.
over here. This allows flexibility in encoding time samples within range and scale suitable for application while maintaining, bro, let's,
Oh, time code. Yeah, now I do remember time code per second. So yes,
yeah.
yes, yes.
So it's like if there the total time
Code per second
sample,
is 24 frames, right? So it would be
huh?
24, 48, like that. So time code per second equal to 24
For
frames a
example,
complete.
if the root layer has time code per second 24, a time code of value 48 would correspond of 2 seconds of real time. Oh yes, I remember. So
But
like
what is
basically 2 frames.
what is
Two
24? No,
frames.
no, no. Two frames are not 24. And that's what it. That's not what it means. That is the
Wait, time
confusion.
samples are used to store time varying data for attributes such as position, rotation, or material properties. When an attribute is elevated at a specific time code, the value is nearly linearly interpolated from the surrounding.
What is 24 over there? I want to know that. What is 24?
Time code per second is 24. That means a time code value of 48 would correspond to 2 seconds. So
Yeah, I know.
basically,
But 24
1
is it
second.
24 frames?
Huh?
So is it 24 frames or what?
I
Like
don't think it's
24.
24 frames. It's just a unitless. It's basically unitless. I think it. Wait, it said somewhere that. Oh yeah, over here. Time code is a point in time with no unit assigned to it.
Yeah, you think of them as frames. Yeah, see, it says over there.
Yeah, exactly. Yeah,
So
see,
that means those are frames, right? 24 frames at that time code per
Wait,
second.
you can think of these as frames whose units are derived from the stage. Yeah, yeah, actually.
So just ask Gemini, is 24, does 24 means 24 frames or not?
Okay. I just
What is it?
yes, conceptually, but with a slight catch.
In standard video, you can absolutely think of 24 as 24 frames per second. However, technically speaking, OpenUSD is the time code because they are completely unitless number inside and you count. Ah, yes, this is what I was looking for. You are you count in integer frames, frame one, frame two,
Oh,
frame
it's
three.
FPS, frames per second. Okay.
So when time is continuous and use floating point numbers like frame. So by setting time code per second, you're telling OpenUSD for every 24 ticks
Mm-hmm.
for a time frame holder is exactly. Oh, okay. So okay, that defines a similar a time for the animation world. So, so every 24 ticks of our timeline ruler. Wait, but what is timeline ruler? What is 24 ticks? That is
Ticks.
confusing.
Ticks basically mean that unitless thing, bro, that we were doing yesterday. You remember? We were dragging the scale from 0
Yeah.
to 90 to see the
Oh
deformation of the.
yeah.
I think
Oh,
that
okay,
is
okay.
what ticks over here mean.
Oh, makes sense.
So time sample is basically the dictionary, right?
Yes.
Oh, beetroot.
Okay. All right. So let's go back to the code.
Okay.
Hmm.
Mm-hmm.
What does the code says? Okay. Now what we have is we have created the stage. We have set start time code for the stage and code for the stage. Then we have created our world default frame and ground. So we have world xform, that is usdgeom.xform.define stage slash world. Then we have stage dot set default frame world xform dot get frame. Okay, all right. So we are defining the entry point for our frame now. And then okay, we are trying to rotate the prem. Okay, using the xform common API on the line 20. Okay, perfect. Then we are creating a ground cube on line 23, and then on line 24 we are again initiating the xform common API for scaling it. Again, trying to transform it. Now the main thing happens in line 27 and 28. So we have static default cube, that is your geom cube dot define. Okay. and then we are trying to display the color attribute, and then we are gonna set the color attribute to something RGB, and then once we have that, we are gonna use expound. We are gonna wrap the cube into an expound common API. Then we are gonna add some translation, and then we are adding an operation. Oh, the scale operation. Okay, but not what do a horizontal scroll. What did it say? Add scale but not author a value. Wait, what does this mean? What does this mean?
Okay,
Add
wait.
scale.
It's setting up a stage, world default prim ground, create ground cube. This is scale and translate. So this is just the rotation of the ground cube. Right. And then static cube with schema defined default scale, no scale, OP authored. Like no.
Oh, okay. Oh, it's creating a scale transform operation on the string, but it's not writing any actual scale number. So USD add the XFORM scale property that includes XFORM operation order, but because no
Mhm.
value is authored, oh, okay, okay, it's gonna fall back to the default scale value that is 1, 1, 1. Okay, that's what it means. This is what it's gonna do over there. Okay, and then this is the non-default cube scale value. Now we are gonna set the scale value 1.5, 1.5 on line 35. And now on line 38, we are defining a static cube that is different from the default cube. Again, we are trying to assign some kind of color attribute to that and using the same XCOM common API. On line 41, we are trying to scale it. Oh, now we are scaling it using the cube set scale that we did define it on line 35. And on line 42, we are doing some kind of translation, right? Okay, so till line 42, we have done two things. We have created two types of cubes. One is static default cube, and the other one is static cube with some translations. Now, on line 44, we are creating an anim cube, right? Okay, same color attribute. Scale is also the same. Again, translation. Okay, same. Now, on line 51, author time samples for scale and translate. Okay, so now we have our XFORM, sorry, an animated cube XFORM API. Okay, we are going to set some state and use our USD timecode sample to set the scale on that time frame. Okay, okay. And then we are going to again set the scale for the end time code, and we are going to set some translation for the same, like the cube animation start time and the end time. Okay. And now on line 58, what we are trying to do over here is read back using resolved scale value. Default cube on common API. What the hell is this? Okay, hold on. Okay, this thing is some kind of complex. We have three, one, two, three, four, five. Five values that are gonna be coming out from. Oh, scale static default. Oh, okay, and then two, wait, and then two, okay, what is the earliest time? Equal to 60. Oh, okay, and the default is, oh, author at default time is 1.5, 1.5 is author at default time, what the hell? No, and static cube with static cube, okay, we have some static cube values, and animated cube at the default time. We have something at our earliest time. Earliest time is 2.5, 2.5. Oh, okay, 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 okay. Oh. All right, I got it. Yes, I got it. It's easy. It's easy. Easy peasy.
Okay.
Now
Explain
that
what is this first part? They're like they are just defining a cube, okay, and they are defining the color of that cube, and
yeah,
then
yeah.
they're
So all in all,
they
like
are
I will
one second,
just,
one second, one second, one second.
just go through the code base once.
Yeah,
You will
yeah,
get it. If you
yeah.
don't get it, you know.
Okay, and then they are using the XForm common API on the static default cube
Okay.
to apply transformation on it, and then they are setting the translate at 801, and then they are do making it exformable by this, and then add scale OP but do not author a value. What does this mean? Add scale OP?
So over here we are just trying to add an operation, but we are not trying to set any scale value.
Yeah,
So it's
but
gonna
what does this
default
operation do?
it scale operation, bro.
Oh, scale like increase size or something.
Scale. So
Okay,
it's not gonna scale. It's gonna default it to 111.
okay.
That would, since no value was passed down, so the scale would be set to like the one default
Mhm.
value,
Okay,
and then
select a non-default cube scale value. Okay, cube set scale. Okay, so if we were to set a scale over here, it would have been three values for like uh right, like XYZ.
what
And
what?
if we didn't leave this empty, like for
Yes.
example, we didn't want to leave this empty,
Dot
there would
set.
have been.
Dot set. We use dot set scale that we have used similar to, like if
I
you go
know, no,
down
no,
into
no. If we want to put a value, like they're saying, right, with do not author a value, right?
this.
And if we did want to author a value, it would have been like XYZ, X comma Y comma Z,
Yeah, like similar to what we have in
in the like this.
yeah, that is basically what we have to pass on over there.
Okay, and select a non-default queue. Okay. Hmm. What if these values were different? Like,
You can put whatever value you want. It's gonna act accordingly.
bro, it's gonna scale differently then. Oh,
Yeah,
okay.
yeah, yeah.
Yeah,
Like
you're
it,
right.
right? Like there
Oh,
is no
we
hard,
will try it in the notebook. One sec.
there is no hard constraint on scaling.
Okay, static cube equals to, now they're what they're doing here. Author default scale, no time sample. So, oh, set static cube scale over here. So they did the same thing over here, but now they are putting this cube set scale as this. Okay. XForm common API, static cube, XForm API, set scale, cube set scale. What is the color over here? 0.8, 0.2, 0.2. Okay. And then animated cube. Same default as static cube
Mm-hmm.
plus time samples. Now, what are they using as time samples? So they are just defining it under the world X form. No, not world X form. Oh, world X form dot get path, yeah. And then anim cube X form API equals to, yeah, okay, same as static. And then author time samples for scale and translate. Set scale, comma USD time code. First animated sample. Oh, cube anim start TC. What was cube anim start TC? Oh my god. 60. Time code was 60 over here. So what does that do? I didn't understand line 53. What is line 53 doing?
So let's go through the line one by one. So on first part, we are picking up our anim cube x form variable that we did set on for line 47,
Yeah.
right? And then we are gonna do dot set scale
Yeah.
to set a scale.
Yeah.
Now the set scale takes two parameters over here based on my understanding. One of the parameter is the three coordinate. It's
Oh, okay. And then
the
time
second,
code.
and then a time code and the start time, like the where.
Oh, is this what the earliest time thing
Yes,
was?
yes, yes.
Um,
So this is where the animation starts.
USD time code dot earliest time. Mm-hmm.
एक second रुकना.
Yeah.
मुझे जो सही लगता है मैं करता हूँ
King is here. The king.
Say hi, DBJ. Say hi to the chat. मैं तुम्हारी स्क्रीन बड़ी कर रहा हूँ. Say hi to the chat.
The king, our angel investor is here.
Angel in अरे फ्रेम में तो आओ. Just what is this? Some peddling happening.
Yes.
USCIS tagged.
वो टक टक कर रहा था कोई, तो मैं पहले मुझे लगा कि पता नहीं कौन है. फिर चलो. All right. So yes, so that is what the second line was doing over there. That we are trying to set our scale and what would at what time sample that scale would get initiated. Sorry, time for that scale would get initiated, and then we have like and on the other line we are doing the same, but at that point we are doing the last sample. Like what will be the value of that sample at that point, the end of the time code,
Mhm.
and we also have some translation animation that is also occurring over there at the same point.
Wait, wait,
And
wait. What line were we on? 53.
yes,
We did okay, so set scale takes in two parameters. One is the scale and then other is the time codes. And then it is setting it to the earliest one that is available over here. But that is not the earliest one. It's just a time code. It's not the earliest one. Um but it's just setting. Oh, okay, I think I understand. Uh-huh. And then set scale 5 comma 5 comma 5 USD time code end. So this is the last sample. Ah, oh, I get it. And then anim q set translate USD q star TC. What does set translate do exactly?
translate, bro, translate, like rotate it.
Like this.
Yes.
Uh-huh. Hmm. I see. Okay. But I don't understand why are we putting in the values over here if we can just do it anywhere we want anyhow.
Wait, hold on. Give me a minute. I'm just sending a text to. Yes. Okay, so you are saying that why are we what?
Why are we putting values in the set translate like as
Okay.
parameters when we can just rotate it any way we want?
But you are trying to do it at certain time code sample, right? Like
But
you
this is
want
not time code. I'm just doing it in real time.
no, but because that is what it is allowing you to do. But if you are trying to create an animated frame,
Mm-hmm.
you're trying to create an animated frame. In that scenario, it's gonna do the whole animation and also gonna do that thing. So if we run our notebook, we will get to know more about it.
No,
Like
if I run this in the USD viewer,
yeah,
you're saying we're gonna be able to do the same thing that we did yesterday.
yes. So it's gonna have the translation and then the
Mm-hmm.
scaling as well, because that's what was
Mm-hmm.
over there.
Mm-hmm. Mm-hmm. Okay. Mm-hmm. Okay. And now what is this doing? Why are there dashes over here?
Dude, this is not this, that's for us to understand. So like you can just go through the code base and then you can go through the print line and then you can look at the output. You will get it. Just go through the line one by one and then look at the output that we are getting.
Default cube fallback scale equals to, and what is
So
this dash dash and
so
then equals to
so that means is when you get the values from that when you so in Python the you
Python.
when we use USD geom dot xform common API and then the whole syntax is gonna output four one two three four five one two three four five parameters, right? But we only want to look at one parameter. That's why we are using default cube fallback scale. There might be some list objects and other things that are coming on over there. But
Mm-hmm.
over here, like they wanted to show us what is the cube's fallback scale value that we are getting
Mm-hmm.
from the output. So that's why we are trying to use that. Like we can also use underscore, print underscore to see what those values are.
Mm-hmm.
But over here, they're just trying to showcase that okay, these are the values that is really important for us to understand. Just
Mm-hmm.
go through the code line by line and then look at the print statements and then you can look at the output to verify. You will be good.
Okay. So fallback scale is USD geom xform API static default cube get xform vectors USD timecode dot default. Okay. Static cube default scale static cube xform API. Okay. Default enemy default. Oh, okay. Cube xform API dot x get xform vectors USD timecode dot default. Mm. Mm-hmm. USD dot timecode dot earliest time. Scale bed and I'm gonna ask Gemini what this part is doing. I don't get it.
Yeah.
So fine. बड़ा ही देश बनाया परदेश में सामने आँखें 53 views today. Damn. Do you know when we had peak viewers?
When we were fighting,
Yeah.
people want mirch and masala. What can we do? Yeah, people are looking at two clowns are fighting over silly things.
Parallel.
Parallel and similar, motherfucker.
So it's awesome. Different points in time. What? Five bucket? It packs an object's spatial properties into five buckets: translation, rotation, scale, pivot. What?
Dude, that's what I'm saying. That line outputs multiple variables. So what we are looking at is the scale variable only. See, it says it packs an object's spatial properties into five buckets: translation, rotation, scale, pivot, and rotation order. The XFORM common API. So when we print it, when we like try to offload it from into a variable, we need to give five parameters over there or five variables, otherwise it's gonna break. So since we are trying to take a look at a single variable, that is the scale, uh, we are putting everything as underscore since we do not want to see what those are. Dude, that is really complex, but if you just go through it, that's what I said. Like, just go through it and look at the values that we are getting, like the earliest time code and everything as an output.
Oh, okay. Print scale static default cube, no author xform op scale schema fallback default cube fallback scale returns identity fallback value author default at default time static cube default scale returns the user author default value Returns the user author default value for anim cube default scale. Mm, the fuck? Scale variable API get X form vectors. Okay. Packs and object spatial properties into five buckets: translation, notation, scale, pivot, notation, order. Because this specific test only cares about scale, how big the cube is stretched. It uses Python underscore variable to throw away the other four pieces. Ah, I see. But it's doing just scale in every one of them, right?
Yeah, it's trying to showcase the
Scale
scale
of
value
each. Okay.
at every timestamp.
When querying a value, get is the same as get time. USD dot time code default. No time code is default. Okay. Mhm. Python underscore variable to throw away the other four pieces of information it doesn't need. Line by line breakdown of the query. Here is what each line is doing in plain English. USD dot time code default. Give me timeless baseline fallback scale of this object. Default cube fallback scale. Oh, for each time. So static default cube north. Ah, I get it. Okay. Interpolated. 3.75. Okay. Got it. I got it, brother.
You got it right.
Yes, sir. Yes, sir. Example two. I think that's the last example. Yes. Fuck, bro. These topics are very big and hard.
Maybe you have a steady background noise that is coming.
Yeah, 1 second. I'm a poor bitch. I don't have a studio. I think I should look for a studio. Okay, let's move.
Yeah, let's scroll down.
No, why is this? Why can't I? This is not collapsible. These menus are not collapsible at all. Let me open this. Let me, no, no way. Okay. From PXR, import, blah, 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 layer one weaker. Okay, what are they trying to do? This example composes layers to show two resolution rules for dictionary metadata like custom data per key strength, as well as relationship list editing. So now the composition index
Mm.
is going to be created based on multiple layers. Uh, layer one path, and then layer one stage. layer 1 X form, and then layer 1 X form prim. World X form custom data, source layer 1. So this is the metadata. Set custom data by key. Set custom data by key, opinion week. Oh, we are setting the same custom data on. Okay, bro. How expensive is your machine? That massager.
$75, not too expensive.
I might get one.
Yeah, dude, this is cheap, like Renfo,
You see,
Amazon, not AliExpress or Temu, unlike our king. Renfo, dude.
please sponsor
I have the
us,
same aim machine for from Renfo as well. Like Renfo, they
bro.
do really have good products.
We are not sponsored, but we are
Yeah,
repping it. Please give us sponsorship. Run from.
one day.
Okay. Okay, so we have set custom metadata on layer 1 X form prim as source layer 1 opinion week, unique layer 1 unique value only authored in layer 1. Uh-huh. Okay. Relationship contribution from base. Look A, USD, geom.xform.define layer 1 stage. Okay, so they have created a new prim under layer 1. Oh no, wait. Looks layer 1 stage, layer 1 path, layer 1 X form is world NX form, and this is world look A. What does this, how does this work? Relationship contribution from base. How does this work? Look A is set to be USD geom.xform.define, and then layer 1 stage is this. What does this mean? Like how is this coming? Oh,
Dude,
it's just setting it. My bad, my bad.
just adding it. That there's a look A X form that is gonna be added onto that stage.
Mm. Mm. Look A. Layer 1 X form prim dot create relationship look targets at target look A dot get path. Layer 1 stage save, layer 2 path, asset value resolution, layer 2 USDA, layer 2 stage, create new stage, layer 2 path. Bro, read this. Read this part. You're mute.
Okay, so we are creating a look A X form on layer one stage, and then we are creating a relationship on that layer one
But
look tar.
how is this part? Okay, 1 second. How is this attribute value resolution animation? Oh, okay, okay, yeah, perfect. Bro, we need
So yeah,
to.
create relationship, and then we are using look targets. Like that is one of the target
Hmm.
naming for creating a relationship, and then we are adding the target using add target API, and then we are using look A dot get. I don't know what the hell is that. Like you have to scroll it. Scroll, bro, brother. Horizontal scroll.
Oh,
Yeah, get path. Look A dot get path. So we are referencing the layer one X form that we created
wait.
with
Let
our.
me. Okay, come back to this line. Layer one stage.
This is the fucking fourth time you're on that fucking line. Okay,
But I don't understand why.
go to Gemini. Go to Gemini. I
Okay, it's
understand it.
just
Go to
okay. It's
Gemini.
just defining it on.
Hmm.
Okay, explain me one thing.
Hmm.
Where did? Oh, I get it now. I get it. No, no mind. Okay, layer one stage, and then this is the path for look A, and then layer one X form. Prim create relationship. Look targets add target look A dot get path. What is this line doing? It's creating a relationship,
Yes, it is creating the relationship and then adding the target.
and
Like
the
what
target is look A get
look
path
so like
dot
whatever the
get
path
path.
that look is, that is the reference point for that
Yeah,
layer
add
one.
target, and then oh, okay. Look targets, and this is the what is this opinion?
That is like just naming. Look targets. That is a naming reference
Okay,
that we will see in USDA file.
okay. It's layer two path asset value resolution layer two USDA. So this is the second USDA file,
Yes,
and then creating a new stage over here as well for layer two, and then
defining in
pretty
an X form.
much yeah, and creating another X form, defining this at world X form prim USD geom dot define dot X form dot define layer two stage comma. So this is the stage and this is the path. Layer two X form prim is layer two X form dot get prim. So this sets this as a prim on in this variable, and then slash world slash X form prim custom data. Okay, now it's setting the custom data by key for layer 2 XForm prim, just like it did it for layer 1 XForm prim. And now this time, okay, so there are two USDA files now with the same path. Not the same path, sorry. The same, what do you say, strength,
Yeah,
because
we have
this is world XForm prim and this is also world XForm prim.
yes.
So is it same strength or no?
Same strength. What do you mean by same strength over here?
Like it's on the same thing, right? Layer 2 XForm.
Yeah, yeah, it's on the same thing. It's on the same thing. So like you can add, but the
Oh, the
file is
files
different.
are different. Yeah, okay, okay.
The file is different.
Okay, okay. So now custom metadata is added over here, set data by key. Relationship contribution from override look B is USD geom.xform.define layer 2 stage. World looks B, looks B, look B. Look B equals to USD geom. Yeah, they're doing the same thing, adding the relationship in layer 2 for look B. Compose stage, first sublayer listed layer 2 is strongest. Why?
Where does it say is the strong? Is strongest. It says over there because that is how we are defining the layer as strong. Strong.
Oh,
Yeah.
that. Oh, we are making it the strongest
Yes. Yes.
by
We are
setting
defining.
it base name. Oh, sublayers, compose stage dot create new stage, compose path, compose stage dot get
Okay,
root
so this
layer.
is where we are gonna use our sublayer thing. So OS. Oh, okay, okay. We are gonna define a sublayer that is our layer two path, and then we are gonna use xform prim to get the prim path. Okay, and then resolve the custom data that we have created for that prim on layer two, and then okay, okay. Look at the output. Look at the output. That would help us to clarify. Go down. Go down. Yeah. Hold it over here.
Hold it.
Yes, yes, yes. That's it. So resolved custom data. What we are getting opinions
Opinion
from.
strong
Oh, okay.
for layer.
And
Oh, okay.
yeah,
That
yeah,
we. Oh, okay. This is what we did.
yeah.
Oh, wait. Now, so if we change it to layer one over here,
Mm-hmm.
layer one path, then we would get the output as weak. Opinion is weak because
Yes.
yeah.
Or if we maybe if we what happens if we take multiple sublayers? I don't know.
Yeah,
What
we
happens if
can.
we take multiple sublayers?
Yeah, we can. 1 second. We can go to the.
Yeah.
Let me finish this and then we'll go to the Jupyter and then we'll tweak both the examples.
Mm-hmm.
Okay, X1 prim. Composed stage. Get prim at path. Resolve custom data. X1 prim dot get custom data. What does this line do? Composed stage dot get prim at path.
It is loading the prim. It is loading the prim that we have.
Mm-hmm.
So we have a prim. So we are gonna load whatever the prim we have at that path. So there is
Oh, so it's going to get it from the layer 2.
no. Yeah. Wait, can wait. Which composed? Yes,
Because,
yes, yes,
yeah, it's going to get it from layer 2 because, okay. So that's going to render the layer 2 X form.
yes.
Source. I did print the source. I think quiz we'll have to do on the weekend, bro. It's too
Okay.
much.
No, no worries.
It's too much. How big is custom properties? It's big. Oh, it is 3 examples. Active and active prims is not that big. Model kind. Oh, model kind is kind of big, kind of not big. Stage traversal. We should aim to complete the beyond the basics module this week at least.
Oh yeah, sure, sure. But okay, so we learned a lot about relationships and then custom key, right? Custom,
Set
wait,
custom data key.
yes, custom data keys, and then how to load them and
Set
how
custom
the
data by key. Dot set custom data by key.
yeah,
That is
and
like adding metadata
how the
for.
USDA renders them inside
Oh, you're reading the key table?
file.
No.
No, no, no. I'm just
Mm.
recapping what we
Oh,
did into the code. Like, so
yeah.
based on the code, what we learned today was basically in the example two specifically, we learned how we can first of all load a
Mm.
layer and then
Mm-hmm.
load the custom keys that we have in that prim and
Mm.
what else and the targets. So we since we did created some kind of relationships. So we have on line 51 we have targets xform dot get relationship look targets. So this is a relationship that we define on layer one,
Mm-hmm.
and this is what we're trying to load over here using the dot get targets, and we can look at the output that we are getting.
Mm-hmm.
So as you can see, we are getting the output as resolved relationship targets slash world looks look B and
Mm-hmm.
slash world slash looks slash look A. So we are getting two targets over here, both look A and look B.
Mm-hmm.
But why are we getting two targets? Wait, let me just why are we getting two targets? Okay, the example layer one adds okay layer two. Oh, okay, 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 okay. So it says over here that uh, the xform dot get relationship look target fetches the relationship property called look targets from the prim world xform prim, and then dot get target does not just return one authored opinion from one layer; it returns the final result or list of relationship targets after USD merges and contributions
So it's
from the.
basically going through the list,
Oh,
right, from strongest to weakest.
yes, yes. So the strongest one over here was look B,
Yeah. Yeah.
and the weakest was look A. So like
Mm-hmm.
in the earlier notes we read over here, resolving relationship. So relationships work differently because they can have multiple targets instead of just picking the strongest opinion. It
Mm-hmm.
combines all the opinions about the relationship and should point to the following specific rule on how to
Mm-hmm.
merge it. Oh, okay, okay. Now it makes sense. Now it makes sense. Okay, so that's
Mm-hmm.
why we are getting both world A, look B, and look A, since it is resolving both the targets at once. That dot get targets. And then we are saving it. Okay, write out the compose stage to a single file for inspection. So what we have XForm, strong opinion, layer 2, blah blah blah, custom look targets. We have look B, look A, and then we have looks, so that is look A and look B. Oh, okay, okay, okay. Makes sense. Oh, shit. Makes sense.
For key value and resolve custom data print key. Oh. Oh, so this is oh. So this function dot custom data, get custom data, is what is doing the value resolution, I guess.
Yes.
right? Uh-huh. Targets equals to x from prim dot items key value opinion strong targets equal to x from prim dot get relationship looks targets dot get targets resolved relationships targets look b look a. I see. Okay. Write the compose stage to a single file for inspection. Value resolution. Oh, so this is the combined file now. Layer look B, look A is okay because it is strong. Uh-huh. String opinion strong, string source layer 2. String unique layer value is layer 1 unique value. Why is this layer 1 unique value?
Because we have set a unique value over.
Custom data by key or unique layer value. Oh, because there was no. Oh, if we had set unique layer value over here as well,
Yes.
then it would have picked up the second one.
Yes.
Ah, I see. I see. So this is basically merging the. Okay. Got it, brother. It was not that bad. Okay. Yeah, it's saying the same thing. But why did it merge look A and look B? Shouldn't it be just look B?
Why would it be look B? Where did we merge first of all?
Bro, look at this. Merge the targets.
Dude, the targets are merged because of the property of value decomposition. It's not talking about the look targets over here, not about over there. It's talking about the custom relationship that we created.
Mm-hmm.
Not talking about the prims.
Source and opinion is often stronger
The
layer.
resolved relationship includes both look A and look B. Look at the
Mm.
relationship. You are looking at the prims, X form prims. You are so look A and look B are separate X form prims, and then when you're trying to
Oh,
resolve.
so the prims will be there.
Yes, but the relationship
Okay.
that you created resolves to a single array of multiple prims that
I
you are
see.
trying to create the relationship of.
Mm.
That's how value resolution works. So key
Mm-hmm.
takeaway: value resolution gives OpenUSD its powerful ability to combine data from multiple sources while keeping the system fast and efficient. This is incredibly useful in real world and workflows. For example, imagine multiple teams working on different parts of a scene. Value resolution seamlessly combines everyone's work into a single model without anyone's contributions being lost. So here's a concrete example with a robot arm. The base layer defines the robot arm's default position at 0, 0, 0. The animation layer overrides this to move the arm to 5, 0, 0 during operation. During value resolution, OpenUSD combines this layer, resulting in the robot arm being positioned at 5, 0, 0 while keeping all the other unchanged properties from the base layer. Oh, okay. So you know the default position that we are talking about, and then we have the what was the other code snippet? Latest. No, what was it? Wait.
Custom data,
No, 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 no. It is talking about the time at that point.
time
Wait,
code,
wait.
time sample.
Yes, time sample. What was the value? Uh, Default cube, animation cube. What was the value, bro? Earliest time. The dot earliest
Oh,
time.
earliest
Okay.
time. Mm.
Yes, yes, yes. The earliest time. So the animation layer overrides this move arm to 500 during operation. Okay, okay. So we have a base layer that is the fallback value, and then we have the animation layer that overrides the opinions of the base layer. It is what we're saying that. So if we have an animation layer that is trying to load the base layer as a sub layer, and we try to put some kind of dot set scale or dot set translate, it's gonna override it definitely, right? Since when you try to author an operation right before, we got that there is an operation set for scale, but there is no value defined, and the fallback value was set to 1 comma 1 comma 1 for that operation. So this is what I think it's saying over here. During value resolution, OpenUSD combines these layers, resulting in the robot arm being positioned at 500 while keeping all other unchanged properties from the base layer. Understanding value resolution is key to working efficiently with OpenUSD's non-destructive workflow and getting the best performance in multi-threaded applications. Woo! Let's go.
Full stop.
Yes.
Okay. Fucking tough.
Yeah.
Bro, it
But
took
dude, yeah,
two
this was good.
hours.
This was like okay. It was trying. It was more of like, okay. How good are you with Python, and
Yeah.
how good are your fundamentals that you have gone through? Like our
Mm-hmm.
weakest point was time code samples, and we
Yeah.
did do a recap about it, and then we are getting to we're getting much more familiarity with xform and how we can use xforms in different way and other parameters that the xform api takes,
Mm-hmm.
and
Mm-hmm.
also the set scale api takes. For example, I did not know that the xform takes two parameters. One is the scale values xyz, and
Yeah.
the other
Yeah.
one was the time code, like at what time, like how to animate those things. Okay, I think
Mm-hmm.
it's gonna get tougher as well, but it's not gonna get that tougher that we won't be able to understand shit.
Mm-hmm. Creating
All right.
composition arcs. What is prim composition? Uh-huh. Sublayer. Oh my god. Bro, each now there's gonna be multiple submodules, submodules.
Yeah,
There's gonna
that's
be
fine.
modules, then there are submodules, and there are submodules, and then there are gonna be exercises. This is gonna be fun, I guess,
Yes.
in USD view.
Yep. All right, guys. It was fun today. We learned a lot about value composition and the basics and
Mm-hmm.
how USD composition and uses value resolution to adapt to layers and to attributes and opinions when you try to render them.
Mm-hmm.
And the most important thing was the difference between parallel and similarity things. Right?
Can you see this?
Fuck off, bitch. Right. Adios, amigos.
All right, let me end the stream.